Good morning. Hope everybody's doing well. A little bit late this morning. I'm sorry about that. I'm trying to get things organized this morning. Welcome to Turfgrass Epistemology. My name is Travis Shaddix. I'm trying a few new things this morning. So for those of you watching on YouTube and listening, wherever you are, if you notice anything unusual, please let me know. I have a few things running in the background. Trying to test a few things this morning. See if they work. Make my life a little easier if it does work. So we'll see what happens. This morning, we have some good stuff today. We have an iron article. I'm going to go over very short. It's only two pages. Nice little article on severely iron deficient turfgrass. And it's one of the few articles, in fact, maybe the only article it is the only article I can remember that shows a turfgrass response to granular iron sulfate. So it can't happen, but I'm going to explain exactly what's going on with that article and why they saw a response, in my opinion. And, go through that today. So that'll be a fun one. It's not normal to see what they saw. And so I wanted to go over that article before I get too far down the road. What else? Went to my daughter's dance recital last night. That was nice. She's moving, I guess, out of whatever she's doing and more into dance now. So maybe that's just the time of her life to do that. So that was fun to do that last night. Let's see. I have an error correction from the other day. I mentioned on a podcast. Actually, I think the video of the podcast or the live version, the video of the live version was released this morning, I think. And in there, I mentioned the correlation coefficient of 90.3%. Like I mentioned in there, we would be 90% confident that we would see a relationship. That's not accurate. That's not the way that data point is supposed to be read. And I want to clarify that. The R square of 90.3 indicates the amount of variation or the amount of error that the model accounts for. The p-value was 0.1%, I think it was. Anyway, the p-value was 0.1%. So I'd be, or was it? Oh, the p-value was 1%. I apologize. The p-value was 1%. So make a long story short is, we're 99%. When you see an R square of 0.903, and then there's a p-value associated with that of 1%, what it means is we're 99% confident that the model accounted for about 90% of the error. We're not 90% confident that there was a relationship. We're 99% confident that there's a relationship, and the model that we used accounts for about 90% of the error. Small little caveat or small little piece of information you probably don't care about. But whenever I notice that I make an error, I try to correct it. I don't want to put out any information that's not accurate. So a little point I wanted to make sure that I corrected that. So if anybody watched that video and noticed that I mentioned that and realized that wasn't correct, you were correct. That wasn't correct. So I wanted to make sure that was clear. I've been receiving a few emails, a lot more responses and comments on my videos. A couple of emails I've been receiving have been just absolutely fantastic. And what I've decided to do is I'm going to probably go over those. I'm going to have like a comments video on Wednesday night. Anybody that sent me an email personally, I won't identify who those are when I'm going over it. I'll leave out any information that it, might be personal to you or you don't, want out there. I won't mention who sent me the email, because when you send me an email, I'm assuming that you don't want the information, going out to the masses. So I won't violate that trust. But I do want to use some of the emails I've been receiving as just a point of gratitude to you all, really, for taking the time to send those emails, the positive information you've been sending me. And at the end of the day, I just want to say thank you for you all sending those emails and encourage more people to just express, how they're feeling about the channel. And I wanted to say thank you for that. So I'll go over that on Wednesday night. And like I said, I'll leave out any of the private information. I won't identify you or anything like that. So if you left a comment in the video, well, that's different because that's all public information. So I'll go over some of those. There've been a lot of good comments. I really appreciate it. And there's a lot of good chat always, and some people actually take the time to comment on the videos, and most of them have been very, very positive. So thank you for that. Good morning, Super TA and Randy and Lush and Brady 419. Good morning, Richie the Lawn Guy, or Rich the Lawn Guy. I don't. Trees down, Lush says trees are down everywhere, had to turn around due to one flow. Oh, so that's over in Massachusetts, I guess, over on the East Coast. Yeah. Yeah, I had some bad weather, I guess, over on the East Coast. And I know Florida was getting hammered a day or two ago. That happens. I moved to Kentucky a few years ago and avoided, for many reasons, but one thing is to avoiding all the hurricanes and stuff and when it was becoming crazy. I came here and I didn't realize the wind in Kentucky can be quite severe as well. Yeah, I got a haircut. If you think the barber is blind who cut my hair, it's because the barber actually is blind when he's cutting my hair, because I cut my own hair and I can't see when I'm cutting it. I'm too lazy to go out and get my hair cut. So I just cut it myself. I hardly have any hair left. So it's like, what the point? What do I care what it looks like, I'm actually waiting. I mean, I'm hoping that it just eventually goes completely bald. So I have to stop worrying about it and have to stop cutting it. But yeah, I got a haircut. Okay. We have an article this morning that is really just a wonderful article to go over, a web propaganda piece. And I want to go over that to just have some fun with it. There is no author on the paper on this particular propaganda piece, so I won't feel bad about offending anybody if whoever wrote it, because I don't know who wrote it. Let's see if I can get it up on there without showing all the other screens here. Oh, I did. I never have figured out how that works. Okay, so this website I pulled up, whatever you call it, or a web article, whatever it is. It's called Iron and Turfgrass. It was put online, it says here, on May 5th, 2021. And it was put on to the Lebanon Turf website. And there's no author. I've looked and looked. I would give credit to the author, although he or she may not want it after I go through it. But I wanted to go through this because this Lebanon Turf web, there's several articles in here that are just wonderful examples of propaganda and true information blended with misinformation. And the question I always ask myself, a lot of it's particularly on iron. I'm fairly knowledgeable on iron. I kind of have a general understanding of the system. I'm not convinced that anybody really understands the system with iron, whether in the soil or in the plant. I've met very few people. Even in the literature, there's only one or two authors who may not even be alive anymore, who I really think understood it. And that's not me. So it is a very complicated issue. There's the redox potential and the changes and the electron donations and acceptance. It's insane, the complexity of iron in the soil. So I'll give them that. I don't know if anybody really understands it. But this article is not that... the content in it is not particularly difficult to actually go measure. And clearly whoever wrote this hasn't actually measured it. So, and I'm going to show you what I mean from that. So let's get through this. It's called Iron and Turfgrass. And we're going to have a scientific article at the end. But Iron and Turfgrass on Lebanon website right now. And this is a very short one. By the way, I have a much better article on this website if they don't take it down. I won't even mention the title because I don't want them to take it down. That I'm going to go over whenever I get to fertilizer blending. Because it's propaganda to an extreme I've rarely witnessed. So I'm going to go over a better one, but this one we're going over is because we're going over iron. So this is why I went to this one today. It starts off and says, iron is considered a micronutrient for turf grass. I'm not going to quibble over small little errors and typos and things like that. I mean, I can be nitpicky and just be annoying if I want to, but there's no point in that. But I'm just saying that it's not considered a micronutrient. It is a micronutrient, but I'm gonna do my best to kind of just pass over little stuff like that because I really want to get to the core of it. Iron is a key component of proteins and plant enzymes involved in nitrogen metabolism, plant respiration, and chlorophyll synthesis. Due to its role in chlorophyll synthesis process, iron level can impact turf color in many situations. That's true. Iron in the plant, as we saw, what was it, yesterday, or the last was on Friday or Thursday or Wednesday. The relationship between color and iron that's in the plant is very strong. And I think we even show that today in this article as well. Turf grass will absorb iron via the roots. The iron will be in a stable reacted form. Examples are shown below. Each source has a different iron content and a different availability to the turf via water solubility. So the reason I said that earlier about I kind of have a general grasp of the system earlier, I said that I often wonder how other people are able to decipher what's true out of this stuff. Because I don't think really anybody understands iron in the soil very well. I kind of have a basic idea, sort of. But I imagine, perhaps incorrectly, that the majority of people don't really have much of a clue at all. And it's those people that are out buying the fertilizer a lot of times and spreading the fertilizer. And I often wonder, well, how would they find out? You know, how this is epistemology, right? So how do we know what we know about iron in the soil? How would just an average Joe, read this? Would they read it as this is true, or would they read it more critically or skeptically? I don't know. For me, I can read these things and for the most part pick out all the flaws and inaccuracies and so forth. But it often concerns me that stuff like this, propaganda like this is written, and I think the majority of the people probably don't care, but probably also don't possess, the people who do care might not possess the necessary knowledge to make informed decisions. And we hear this stuff over and over and over again, and we eventually become convinced that it's true, and in fact it may not be true. So that, I don't know, that concerns me. I don't know what I'm going to do with it, but anyway, I guess that's why this channel exists. Anyway, he shows ferric sulfate, ferrous sulfate, iron sucrate, ferric oxide, ferrous oxide, chelated iron, and organically derived iron. He shows a list of these products. There's a whole bunch of other iron sources as well. But for the granular sources, those are most of them. The words ferrous and ferric designate the oxidation state of the iron atom, ferrous referring to Fe2, which is relatively soluble in water, and ferric referring to Fe3, which is only somewhat water soluble and only in acidic soil and acidic environments, pH of 6 or less. We're going to get into pH and iron. Iron oxide typically contains both ferric oxide and ferrous oxide. Iron sucrate is iron oxide combined with sugars to reduce staining risk, discussed later. Now, we've discussed that before. That is true. Iron oxide is just iron sucrate is iron oxide that's just been crushed, or it's the leftover, remnants of iron oxide that they reaggregate with sugars. Chelated iron features iron paired with a chelated agent that can be spray applied. It is easily absorbed by the turf. I don't know what his definition of easily is, but we're gonna discuss this. Organically derived iron refers to the iron present in sources such as biosolids and compost, normally at a very low percentage. Now, that's the one source of iron I was never able to actually test because I didn't want to bother trying to balance out everything. When you're dealing with iron, particularly in turf grasses, when you just when there's a tremendous amount of organic material and lignans and all sorts of stuff, the solubility is I can't express it enough. It is immensely complicated. And when you're dealing with an organically derived iron and you're trying to determine whether or not there's going to be a response to that specific form of iron, it's not easy to remove all the other factors and only look at that. It's very difficult. And I just didn't want to mess with it because it became very, very challenging to figure out. I wanted to know, could you actually get a response only from the iron from, say, millorganite or something? And I never bothered doing that because it was just too difficult. For turfgrass, the generally accepted target range for iron level in soils is 30 to 100 parts per million. That's definitely not true. I'm not convinced at all that that's true. I should say I'm not convinced that that's true. There is no consensus accepted range for iron on soil tests. So to say this 30 to 100 parts per million is just being naive or ignorant, or I don't know what it is, but that's not accepted by soil scientists, at least not this soil scientist. Turf deficient in iron suffers from chlorosis identified by a pale green overall color. Usually the reason for chlorosis is that the iron in the soil is not available to the plant, especially in alkaline soil conditions. If the soil pH can be adjusted down to 6 or so, the iron in the soil will become available and the turf color should gradually improve. Now, if there is one soil scientist that I would say understood iron at least better than anyone I have been ever aware of, it was Dr. Lindsay, who published all these iron papers in the 80s and 90s. And I don't think he would agree with that statement. I can't read his mind. But when this particular person is saying adjusting the pH down to 6, the iron in the soil will become available. I will show you my own research where we applied iron sulfate to many soils. One of them as low as 5.1. I think another one was 5.3, which obviously is below 6. And that iron became unavailable within 24 hours. So when you hear things like this, it can kind of sound convincing because you might be indoctrinated into believing that lowering soil pH will somehow result in an increased greening from soluble iron. You may have heard it so many times that now you believe it. When in reality, there's very little evidence to support that. Clearly, there's evidence to support the solubility of iron changing as pH goes up or down. I'm not here to debate that. What I'm talking about is in a reality, in an applied practical setting in the field. If you're going to reduce the pH from 7 or 8 down to 6 or 5.5, you're going to take the time and money to do that because you think it's going to increase the soluble iron in the soil to a point where you'd see a turf response to that. That's not supported by most of the evidence that I'm aware of. And this particular person says, reduce it down to 6.0 and it'll be soluble. And I'm just not convinced that that's true. And I'll show you why I'm not convinced that's true in the coming weeks. Some turf fertilizers have an iron content of 1 to 3 from iron oxide. The intention of this fertilizer formula feature is to supplement the iron level resident in the soil. I would say that that's probably untrue. I mean, iron oxide isn't going to... The solubility of iron is dominated by the insoluble form of iron in the soil, by the solid form, I should say. It could be not just insoluble, it could be like a amorphous sort of iron. That is the driving sink of iron is pulling all that iron out of solution. That's the driving factor, is the solid phase of iron in the soil. That is true. But the intention of the fertilizer formulation containing iron oxide is not that. Coming from someone who's blended thousands of tons of fertilizers, I can tell you with a great deal of confidence that the intention of including iron oxide in fertilizer formulation is because iron oxide has the highest percentage of raw material of iron in a raw material, 50 or 55%, depending on where you get it from. And you only have to add a little bit in there to get the iron on the fertilizer tag to go from 0 to 3. So when you're dealing with a fairly full ton of fertilizer, you may only have 50 pounds or 100 pounds left that you can add something into it. Well, you're not going to increase the percent iron in the fertilizer from, say, an EDTA or an EDDHA that much. Very little. And you're talking on the decimals of percentages when you're going to add it into a ton because the raw material is so low. But the raw material of iron oxide is 55% or 58%. It's very, very high. And so you only have to add a little bit to get that percentage to go up in the ton, and that can convince people to buy it. That's, in my opinion, why iron oxide is used in granular fertilizers. It's a game of deception. Whether or not the iron actually results in a turf response is not the responsibility or the interest of the blender. They're simply adding that because they believe that the end user has asked, get my iron up to 3% or 5% or whatever. I want iron in there. Well, they can't do it oftentimes with low analysis raw materials. They have to use high analysis raw materials. And the highest is iron oxide. This is an economic benefit, but the iron content is derived primarily from ferrous oxide. So the soil pH needs to be 6.0 or below to see any effect. So he's not even implying, he's stating. He's stating as a matter of fact that the iron oxide in this is not going to be soluble until it gets below the soil pH gets below 6.0. It says any visual effect such as a deeper green color will also be minor and slow, perhaps several weeks. It'll be several weeks. It will definitely be several weeks before you ever see a turf response to iron oxide. That iron oxide is so strongly formed, I guess that's the practical way of saying it, for any practical reason, practical purpose, any practical definition, it's never going to be soluble again for any, in any meaningful sense to us. Geologically, it will become soluble at some point in the future. Okay. But for us, I'm talking about any time between the next 6 months to the next, say, 10 years, you're not going to see any visual benefit, any response to applying iron oxide, even if the pH is below 6.0. As long as as long as the soil pH remains in the range for adequate plant growth, optimal plant growth. I mean, if you go down to 1 or very, very low, ridiculous pH, I imagine there'll be some iron become soluble from iron oxide that low, but that your turf would be dead by that point anyway. So as long as it's, in the 4s or 5s, where your plant can probably survive still, you're not going to see any appreciable amount of soluble iron from iron oxide. So this is again, I'll say I'm not convinced that that's true. And I'm becoming more and more convinced that it is not true. So there's a difference between saying I'm not convinced it's true versus saying I'm convinced it's not true. And I'm slowly being convinced that it's not true, which is a much stronger statement than saying I'm not convinced. Anyway, it's not semantics. That's for another conversation in the future, maybe. When applying granular iron compounds to the soil, be aware of the risk of staining on flat surfaces, particularly light colored concrete. If the iron particles are crushed on the concrete by tires, human shoes, or even heavy sweeping, rust-colored stains will appear that can be found objectionable and difficult to remove. Now, this is, I don't know how to explain this, but I mean, technically it is true, but it's not true. I mean, it doesn't have to be crushed. Whoever wrote this has never actually gone out and measured and taken the time to determine iron staining from these iron sources, because you don't need to crush these particles. All it has to do is remain on the surface if it's soluble, and water to come in contact with it, and it'll dissolve and stain within, it depends, but within 5 to 20 minutes, you're going to see a red or brown stain on the concrete from something like iron sulfate. You don't need to crush it. Iron products based on oxide or sulfate are known for this undesired property. Now, I've done a lot of staining work with iron products, which I'm about to show you on the very next slide, where I've never seen a staining from iron oxide ever. And I don't think it can really occur because the staining itself is a chemical stain that is the result of the oxidation of the iron on the surface of the concrete or paver or whatever. And in the case of iron oxide, the iron's already been oxidized. There is no more iron to oxidize. So from iron sulfate, it's soluble. And so when the iron comes in contact with dissolved oxygen in the water, it'll oxidize out. And when that happens on the concrete surface, it'll form that red or brown stain. But iron oxide will not stain. as far as I'm aware. I've never seen it stain. I'll show you a slide in a second that showed it didn't stain. So again, I just don't think the person who wrote this knows what they're talking about. Particles landing on susceptible surfaces should be lightly swept or blown into the turf. Iron sucrate can be used as an alternative to reduce the risk, but particles should still be removed. Iron sucrate does reduce the risk of staining, but there's no known response to turf grass from that product, so it's kind of useless. So, I don't really fault the person who wrote this for not understanding iron. I don't understand iron, to be frank. I mean, I don't know if anybody does. But when you're talking about staining and stuff, that stuff's easy to measure. All you got to do is go out and put out some iron sulfate particles on your curb and sprinkle a little water. Don't use bottled water. You got to use water that has some dissolved oxygen in it. But when you put a little water on there, it'll stain in about 5 or 10 minutes. It's not complicated. Do it next to oxide, and you'll see nothing happen. And here's what I mean by that. This is a project that I did years and years ago. In fact, let's see when it was. 9 years ago. So 9 years ago, I was working for a fertilizer company, and I did this little project at my house in Gainesville. And I took all the iron granular products that we had available through the blending plant, as well as manganese and magnesium products. And I put them all on one paver to get one shot of them all at the same time. So let me explain. I'm not going to play this video because I don't like listening to myself on this video. This video has me in it, and I don't want to listen to it. So anyway, I used all the iron, manganese, and magnesium options that we had available in the blending facility. And I want to walk through that with you here, so we're all on the same page of knowing what's going to happen or what can happen from the application of iron products on concrete, because the idea of oxides can stain is out there. The idea that chelates won't stain is out there. Okay, so let's look and see what happened. Just so I set the stage here, what I did was I took a few granules of each of these products, each of these raw materials. So just straight iron sulfate, just straight iron EDTA. And I put 2 or 3 granules in this little squares. You'll see the numbers on the screen here. For those listening, I have a paver in front of me, and there's little numbers from 1 to 20. And it's a square paver. And in the top left-hand corner, I placed some granules, and then I moved to the right of the paver. And then I moved down, and I put another row of granules. And there's 4 rows. There's 4 rows and 5 columns. And there's just a few granules that I put in each of the little spots designated by the number. And the first number over here in the top left-hand corner is a dark red-brown stain, and that came from iron sulfate. The next one over came from polymer-coated iron sulfate, and you can only see a few little dots where the iron dissolved through there, okay? So the idea that you can slow release, so what this means is, for the difference between these two, is that you're not going to see a stain from polymer-coated iron sulfate, but the oxidation of iron will occur. You can see 2 little dots from the polymer-coated iron sulfate. The oxidation of iron will still occur once it dissolves through the polymer membrane. So it can still happen. In other words, the iron that's going to be released from that is still going to oxidize. It's still going to have very little benefit to the turf. Not just because you're slow releasing, it doesn't negate the oxidation process. Number 3 is VIG iron. VIG iron is a water treatment residual that they treat not wastewater. Actually, it's not a water treatment residual. It is a water treatment residual, but not from wastewater. It's from like river water, if I remember correctly. Could be wrong on that. Someone can correct me and put it in the notes. But you see very little staining from that, but the staining's still there. Now let's look at iron chelate, polymer-coated iron chelate. The polymer did not do much at all to this particular chelate. This was EDTA. And you see a very dark brown red stain from the iron chelate polymer coat. And right next to it is the same chelate that's not polymer-coated, and you see a red stain, dark red brown stain. So this concept or this idea that floats around in the turf grass sphere, oh, use iron chelates, it won't stain. Well, this would indicate that they do stain. Okay. Iron sucrate is over here. This number 6 is iron sucrate, and you see a grayish sort of haze of a stain over here. Iron sucrate is iron oxide. It's just been crushed. So this little gray stain, I didn't get a macro or a close-up photo of this, but this grayish stain is not a stain. It's just the particles have been dispersed. It's actually that gray color is actually particles of the material itself that didn't dissolve it dispersed into the actual concrete, porous concrete itself. So it's not staining the concrete, but it does give it an appearance of grayness. And then 7 right next to it is iron oxide. Right here is iron oxide. So on that article it's saying iron oxide is notorious or well known or whatever for staining. Well, no, it's not. Iron oxide's already been oxidized. Okay. It's not going to stain. It's also not going to provide, and that's the reason it's not going to provide any value to your turf. There's no solubility of the iron in the iron oxide granule to start reacting. There's nothing there. 8 is activated sludge. So here is this was not milorganite. This was either hewactinite or the Jacksonville biosolids. I can't remember. But there was no staining from this. It doesn't mean there wasn't any iron being released. Maybe it was being released and it was preventing it from staining, or maybe none of it was being released. I don't know. But there was no staining from activated sludge or biosolids. The 9 is a frit. Which, if you don't know what frits are just like a grouping of oxide mineral or oxide micronutrients, and we didn't see any staining from that. And then 10 is a 5-in-1 product that's used in nursery that has all 5 forms of iron: oxide, sulfate, chelates, all these things in it, and you do see some staining from that. So the article we just mentioned about oxide and sulfate staining, sulfates will stain as much as anything. They will stain some concrete. They'll stain wood. They'll stain whatever, light poles, and they'll stain metal, whatever. It will stain, but oxides will not stain. Oxides are useless in turfgrass management. Agronomically, they're of no value. So don't think, oh, well, I'll use oxide because it won't stain. It won't stain. It also won't provide you any benefit at all. Okay? It's already been oxidized. We need to use that iron before it's been oxidized. Just because we're here, and I'm probably not going to go back to this anytime soon, the manganese and magnesium are on the next 2 rows. Manganese oxysulfate is the first number here, and we see a light yellow, orangish haze of color that's been stained. So that's oxysulfate, a blend of oxide and sulfates, and you see a staining there. And then right next to it is manganese sulfate. So we have manganese sulfate number 12, which is a dark red, brown, severe stain, compared to iron sulfate, which is also a dark red, brown, severe stain. I could not tell the difference between these two. If you gave them to me and you showed me 2 stains, I wouldn't be able to tell the difference between the 2. One's manganese and one's iron. So if you have manganese sulfate in your fertilizer, it is soluble, and it actually will remain soluble a little longer in the soil than iron, depending on the pH, but it will stain. It will stain just as much as iron sulfate. Manganese sucrate, so it's the same thing as iron sucrate, nothing there. You see a dispersion of the particles and you see a gray haze. 14 is manganese chelate, so here's chelated manganese, and you see a stain. It's not quite dark brown red, but you do see a stain from manganese chelate. And then NutriPlus was a nursery material. And then the next row down, you see all the magnesium sources: potassium, K-mag, polymer coated K-mag, crop mag, dolomite fairway grade, and dolomite micro grade. And you don't really see much stain. You might see a tiny bit from dolomite fairway grade, maybe, but that's not much there. So the point is, magnesium is not going to oxidize near as readily as the irons or the manganese. And I've mentioned that before in a prior podcast. Magnesium, well, did I say that backwards? Magnesium will not oxidize like iron and manganese. And magnesium remains soluble for prolonged periods of time in the soil. It is less affected by pH, and we have very little likelihood of seeing a response because it remains soluble in the soil. The soil already has soluble magnesium in it in many cases, so adding more isn't going to help. But when you apply it to concrete, you're not going to see much at all in terms of staining from magnesium. Okay. So I just wanted to mention that while we're here. I thought it was a good opportunity because we had the Lebanon propaganda piece saying, whatever they wanted to say about iron. It's their website. They can say whatever they want to say. And I can take their website and explain to you why you shouldn't believe much of it, because lowering the pH to 6.0 is not going to suddenly solubilize iron from iron oxide. I'm going to show, again, I keep saying I'm going to show you. I'm trying to get chronologically through these papers because there's many more important papers than my papers. But my papers are at the very end. I'm going to show you that. where iron oxide and sucrate and all these things aren't going to result in much of anything at all. And certainly the solubility of iron, even from soluble iron sulfate, doesn't stay around for more than about 24 hours, even when the pH is down to 5.0. So iron from iron oxide sure is not going to do that. Okay, so I do feel some sympathy, or I don't know what I feel. It's just like when I read these articles, it's easy for me to read through there and go, oh, that's just a bunch of nonsense. But I often wonder, like, well, what is the masses? How do the masses receive that information who might not be knowledgeable on the iron issue? I don't know, but we got to figure out some way to get this information and knowledge to you guys so you can make better informed decisions, not be taken advantage of, I suppose, is my interest, I suppose. Okay, so let's get that's that. Let's get into the article for today. It's very short. Before I get there, let's see if there's anything interesting in the chat. Valerio Merli. Okay, hi, Valerio from Florence, Italy. Nice. I have not been to Florence, Italy. I have been to Italy once or twice, I think. I forget, once a couple times, I think. And I prefer to get out of Rome. I don't like to be around like the big touristy things. I like to go and like go into a house with like a real Italian family and sit down. And I want to know like whether I like it or not is irrelevant, but I want to know like how does a normal Italian family behave and eat, and what's their daily routine like. So I've been to Italy. I've been to Rome once, and I preferred it when I got out of Rome and got it more into the countryside part of Italy. My wife is actually Italian. She has an Italian birth certificate. My children are Italian as well. They're Brazilian, yes, but my wife's dad is my wife's dad's Italian, and my wife has an Italian birth certificate and passport, and so does my son. So we've been there once or twice. It's nice. Polo Fields in the house. Good to see you, Polo. Moaning. All right, guys. Thanks for being here today. All right, the article the title is Correcting Iron Deficiency of Kentucky Bluegrass. This was published in HortScience in 1984 by Minner and Butler from Colorado State University in Fort Collins, which is where my family lives. They live just south and east of the university there. Haven't been out there in a few years. This is a particularly interesting article because, one, it's very short, but you'll be hard pressed to find results like this in the literature anywhere. It is not common to see the results that they saw here, but there's a very specific reason why I'm convinced they saw this. It's not a bad reason. I mean, they did everything correctly as far as I can tell, but it's important to understand the context of what happened when they put it down, or the iron deficiency state of the turfgrass when they started the project. Okay, so for those of you joining us or you're new to the channel, I'll read through the introduction briefly. I won't go through the whole article. I'll only read some of the highlighted green areas, and we'll go from there. Iron deficiency of turfgrass grown on alkaline soils are very common, but very little work has been done on the problem. This was in 1984, don't forget. Haravandi, which we went over this paper, Haravandi paper, indicated that iron chlorosis varied among Kentucky bluegrass cultivars. That was the one that had 25 cultivars and showed very clearly that there was not a relationship between soil pH and soil available iron. It also has been reported that total plant iron and turfgrass color positively correlated with chlorophyll content. That is one thing that is consistent in the literature. It's very consistent in the literature. The amount of iron that's in the plant is related to the amount of chlorophyll in the plant, and that will be related to the color of the turf. That much is pretty consistent. You'll have R squareds of 0.8 to 0.9 or higher or greater when you're talking about what's in the plant. It's what when we try to take what's in the plant and correlate it to the soil or correlate it to what we're applying, and that's where the relationship takes a dive quickly. But once it's in the plant, we are convinced, or I'm convinced, that the iron in the plant does have a direct relationship to the chlorophyll and the color of the plant. That much is pretty clear. There is little information comparing iron product rates, residual effects on turf quality, and influence of plant iron on chlorophyll content. Consequently, this research was conducted to gather information on iron fertilization of Kentucky bluegrass turf. Iron treatments were applied to a 2-year-old uniform chlorotic as determined by tissue test and ratings, Penstar and Falking Kentucky bluegrass turf on September 5th of 1981. So, this was located in Fort Collins, Colorado. Let me finish this. The plot area annually displayed iron deficiency symptoms from June to October. No nitrogen fertilizers were applied during the study except as indicated. So what's important about this study is that this turf was severely iron deficient. It was iron deficient to the point that adding nitrogen resulted in no response, which is exceedingly rare. I would say greater than 99% of the time, you're going to see a turf grass response following the application of nitrogen, particularly ammonium sulfate. And they applied ammonium sulfate in this study. We're going to show that. And they didn't see a response. But they did see a response to iron. So the point is, in this preamble here, is to set the stage. We're not dealing with a normal turf grass situation where you want a little extra color. We're dealing with a turf that is, the growth of the turf is severely reduced, not because there's no nitrogen, there is nitrogen, but because the iron is so low, it's holding back the growth rate of the turf. Okay, that's going to become critical. Tissue used, so we're going to go through the materials and methods, and we'll finish up that up. Tissue used for chlorophyll and iron determination was collected on September 22nd, 81, and September 24th, 82. Okay, let me go through the rest of the materials and methods, and then I'll come back to the products they used. Routine soil analysis was done on the composite sample taken from the test area on September 5th, 81. The test area had a pH of 7.7 and available iron content of 9.3 parts per million. Treatment of plots with nitrogen. Okay, that's the results. Okay, so let's go back up to the actual products that they used. So table 1, for those listening, I'll describe what's going on in table 1. This has all the iron sources. They have 1, 2, 3, 4, 5, 6, 7 iron sources, and they have a control. Okay, so the first iron source is iron EDDHA, and that came from a product called Ferroplex 138, and it had 6% iron in it. Then they had this iron product that I've never used called iron polyflavonoid. It's called, the brand name I guess was called Rayplex, with a 9.6% iron. Sequestrine 138, iron EDDHA, so it had 2 forms of EDDHA, or 2 sources of EDDHA. Then they used DTPA, which is sequestrine 330, which is around still today. Then they used iron sulfate as the salt, and then they used ferrous ammonium sulfate. I recently came across something on YouTube where someone said, "Oh, I discovered ferrous ammonium sulfate." Well, okay, great. I'm glad you discovered it. It's been around for decades. Okay. We're going to explain today. This is going to lead back to the other articles I talked about last week about nitrogen and iron and applying iron with nitrogen. And then they had a source of mine tailings that was an acid iron. And it was primarily iron sulfate. It was iron sulfate 3. I'm not exactly sure how to describe that other than they probably had a byproduct source or something that had acid mine tailings from probably a mining facility or something. Who knows? Okay. Then they also applied ammonium sulfate. Now, the rates they used of this, okay, the method of application. Let's go to the method of application they did first, because they don't do a really good job of describing this, but in the table they explain it. The DTPA, EDDHA, the iron polyflavonoid, and the other source of EDDHA, they all went out as soluble. Okay, spray. They sprayed those out. And they sprayed those out at about 4 pounds of iron per acre. 4.2 or whatever that ends up being. Okay, so I would expect to see a response at that rate of iron per acre. The dry or the granular forms of iron they put out, they did the acidic iron, the acid, the mine tailings, the ferrous iron sulfate, ammonium sulfate, sorry. And then they did the ferrous sulfate as granulars. And then they did the ammonium sulfate as granular. Okay. The granular forms of iron went out at about 22. Well, let's just do the math. I'm going to get this right. Did I already remove that? Oh, I didn't. Okay. So the math on that is, what was it? 24 kilograms per hectare, which is 21 and a half pounds per acre. So the iron they put out as a granule is 21 and a half pounds per acre. Then the ammonium sulfate they were applying was roughly 1/3 of a pound of nitrogen. Okay. And then they had a control. So that's the setting. We're in Fort Collins, Colorado. We're dealing with very, very iron deficient Kentucky bluegrass. We have several sources of iron. About 4 of them are soluble, sprayable, and then 4 of them are dry. And we're applying the spray grade ones at about 4 pounds per acre, and we're applying the dry ones at about 21 pounds per acre. All right? So let's look and see what happened. Treatment of plots with nitrogen from ammonium sulfate provided no greening, while all iron treatments substantially increased the greening color of the turf. So let's look at this table 2, and you'll see here the control, which we received nothing, and right above that, which I've colored in yellow, right above that is the ammonium sulfate. The control on September 13th was a 2 on the color scale. The ammonium sulfate was a 2. On September 22nd, it was a 3.5 and a 3. And then the next year, so 360-something days later, the control was a 3.7 and the ammonium sulfate was a 3. So they applied this 1 year and they measured the responses and they waited for another year, didn't do anything, and then they measured it again a year later. That's what they did here. So to see this, when I see ammonium sulfate applied at about 1/3 of a pound per acre, and you see nothing happen, particularly if it's ammonium sulfate, there is something else going on there. And it's very uncommon to see turf grass stunted to this degree as a result of deficient iron. But that's what they did because they applied iron up here on the same date, September 13th, they did the ratings. The control and ammonium sulfate were a 2, but all the iron sources resulted in a minimum of a 6 and a maximum of a 9 in color. Okay. Even from the granular products, they applied iron sulfate and got a 6.2 from a 2. They went from a 2 to a 6.2 with granular iron sulfate. That is exceedingly rare to see. I'm going to explain a little bit as to why I'm convinced that happened. Okay. As soon as I get through this, I'm going to go to another article briefly and describe what's going on here. Because in the past, you've heard me say, the chances of seeing a turfgrass response to granular iron is essentially 0. It's very, very low. It's particularly iron sulfate that's not protected by chelate. You're almost never going to see a response to that. Well, here's an example of seeing a response to granular iron sulfate. Okay, we can't take 1 paper or 2 papers or 3 papers. We have to take, as best we can, the entire body of evidence. And when we're talking about anything, in this case, we're talking about iron, and the entire body of evidence includes at least 1 paper that showed a response to granular iron sulfate. But this is not a normal turf grass. This is not a turf grass or a lawn that's looking 5-6, looking green. We're applying a little nitrogen, it's looking good, and we apply a little granular iron and make it look better. That's not this. This is a situation where the turf is not acceptable. It's not growing even with nitrogen. Okay, that's critical to understand. So we see on the September 13th rating date, we see the soluble sources being EDDHA, polyflavonoid, and DTPA, all resulting in a color response greater than the granular iron sulfate or the ferrous ammonium sulfate. So if you ever apply ferrous ammonium sulfate and you think, oh, I'm going to see a better response using nitrogen, it goes back to the other article the other week. We're going to apply iron with nitrogen. We're going to see a better response. Here's yet another example where ferrous ammonium sulfate or iron applied with nitrogen did not result in any additional double dark greening, because it went from the ferrous ammonium sulfate, straight up iron sulfate was a 6.2, and ferrous ammonium sulfate was a 6. A week later, we see ammonium sulfate was a 6.8, and the ferrous ammonium sulfate was a 7.8, which was statistically the same. There was no difference between these two right here. They were the same. And then a year later, the color response, which lasted a year, which is unheard of from iron sulfate. Absolutely unheard of from iron sulfate to see a response a year later, from 8 to 7.7. So there's no difference between applying iron sulfate or applying iron sulfate with ammonium sulfate. There was no difference. So paying more for the ferrous ammonium sulfate is not likely, at least in this case, in this particular study, did not result in any additional benefit to you as the consumer or the applicator. But there's a reason why I think that this response lasted this long. And the same thing happens with other elements. You have to understand that this is extraordinary results. This is not normal to see a response last a year to applying iron. But the same thing can occur even from other elements. If the turf is so retarded or so the growth rate is so slowed because of a nutrient deficiency, okay, let's take sulfate, for example. If the turf grass isn't growing because there's no sulfate, then you apply a source of sulfate, then that turf will continue to grow until it depletes the source of sulfate, until it depletes all that sulfate, and then returns back to its deficient state. So as long as that's there, it'll keep growing. It's no longer slowing the growth. And in this case, the iron sulfate from that early application, apparently, the iron sulfate is probably no longer available in the soil at all. But the iron went into the plant, and perhaps it recycled. Who knows what happened? But the restriction on growth was alleviated by applying the iron sulfate, and that lasted for a year. Okay. It's really unheard of. It's bizarre, okay, to see that magnitude of a response last that long. But it did. Okay, so you see a response immediately after application of September 13th of 81. You see the response continue with September 22nd of 1981. And then in September of 1982, the only responses that you're seeing, or not the only, but the responses that you're seeing primarily from that prolonged time, a year later, are from the dry granular sources. All these are dry sources, and you're seeing the color response last that long, whereas the foliar responses have already been depleted. They've already been exhausted, and there's no longer a response to the foliar application of iron. Okay, so it can happen. You can see a turfgrass response to granular iron sulfate. It's just not normal. Okay, so if you have a situation like this on cool season turfgrass, on Kentucky bluegrass, and you're applying ammonium sulfate, and you're like, nothing's happening. This is not growing. I don't know what's going on. It very likely could be a nutrient deficiency, and alleviating that nutrient deficiency may result in a prolonged response. And in this case, from iron lasting a year. Okay. Let's continue through here, and then I'm going to go back and explain a little bit as to how that's possible. Okay, the iron materials used in the study were grouped into three categories: chelates, salts, and acid-treated mining tailings, which had a pH of 1.9. Chelates and acid-treated mine tailings were used at labeled rates. Application rates for the iron salt have not been reported. Therefore, they were applied at various rates from 0 to 96. Now, in this one, they're only showing the 24 kilograms, which is 20 pounds of iron per acre. But they did a rate study as well, all the way up to 96, which made about 90 pounds per acre. I'm going to show that. That's what a calibration is. I'm going to show you exactly how a calibration study is supposed to be conducted on this paper. All iron treatments in 17 days significantly increased turf greening, which is what I showed. During this period, only iron salts applied at 24 kilograms, 20 pounds per acre, exhibited significantly lower color ratings than the other iron treatments. So that's what I'm talking about. These dry granules here, they showed a lower color at the beginning than this foliar. but they still showed a response to the control. Iron salts applied at 45 pounds of iron per acre had a greening response similar to the chelates and acid mine tailings. So they didn't show that in this particular table. I don't know why they said table 2 in figure 1, but they don't have the 48 kilograms in there. But they're saying that the 48 resulted in the same as 4.8 from the chelates. So 45 pounds of granular was the same as 4 pounds from foliar. Grass treated with iron salts and acid mine tailings was significantly darker green than grass treated with chelates after 384 days. So what I mentioned, after a year, the granular was still superior, was superior than the foliar. Chelated treated grass was far below established acceptable color levels of 7, so the acceptable level was 7, and was similar to the control in September 1982. So a year later, they were unacceptable. Ferrous sulfate treatments were applied at 0, 12, 24, 48, and 90. Okay, so that was the calibration they did. I'm going to show that. Regression analysis indicated that turf color exhibited a linear response to ferrous ammonium sulfate. To iron sulfate. Up to about 45 pounds per acre. There was no further increase in color beyond this rate. So above 45 pounds per acre of granular iron sulfate, they didn't see any additional benefit. Interpolation from figure 1 indicates that acceptable color ratings would have been achieved with application rates of about 24 pounds per acre. Significant correlations were found among turf color, leaf total iron, and chlorophyll content 17 days after treatment, but not 384. Okay, so let's look at this calibration. This is the way a calibration is supposed to be conducted. I can't get it all on the screen here. But we're looking at a graph here for those listening. Color ratings on the y-axis and ferrous ammonium sulfate rate is on the x-axis. And what he's done is he's drawn a line here at 7. He said, arbitrarily, granted, but that's what you got to do with turf grass. He said 7's the minimum. So what rate of iron would result in a color rating of 7? And when you run these different rates of iron and you do their color ratings, you can put these data points on a graph, and you can run a regression and say, okay, what's the equation? Well, here's the equation right here, regression equation. And you can use this equation to determine what rate of iron would cross color rating of 7. And he did this and determined that it was around 25, 26, or whatever the exact number was. I don't remember. 27 kilograms of iron, which would mean about 24, 25 pounds of iron per acre. That's the way you're supposed to do a calibration, okay? You see the R squared here is 0.9 and 0.8. It's all good. It's from a granular application, but so I'm comfortable with that. The correlation between what's in the plant and what the color is over here on the right, where we see table 3, and we see 0.9, 0.87, and 0.84 between the turf color and chlorophyll, turf color and plant iron, and chlorophyll and plant iron. Very strong relationship between what's in the plant and what chlorophyll is in the plant, or what's iron's in the plant and what you see in the color. Very strong relationship. It's very common in the literature to see that. No worries there. But I want to explain a little bit as to why it's possible, although it's very rare, it is possible to see a turfgrass response to granular iron. But it has to be under, in my opinion, it has to be under a very specific situation, which was what occurred in this paper. Because, let me go back to me, because the turfgrass was so deficient in iron, it was at a stage or a state that is not common with quote-unquote iron-deficient turfgrass that you normally see. In other words, iron-deficient turfgrass that you normally would come across in a normal settings would respond to the application of iron in terms of color. But they're also responding to nitrogen. In other words, the iron is not so low that it's retarding the growth or it's restricting the growth. In this case, it was severely low. It was the element on, Liebig's law of the minimum. It was the element that was that low. And I don't care what else you add to the system, you're not going to change the growth rate because that element is restricting the growth. When you alleviate that, suddenly the turf takes off. Okay. So, how is it that granular iron sulfate, which I've stated is almost never going to result in a turfgrass response, how is it that it may result, or it did result in a turfgrass response here under severely iron deficient bluegrass, whereas it very likely will never result in a turfgrass response under non-severely iron deficient turfgrass? If we go back to this paper the very first paper I ever went over, which I'll probably go over it again. I went over this, not live. I did it here in my office. the very first video. It's called The Chemistry of Iron in Soils and Its Availability to Plants. Now, this author, in my opinion, is the only author that I would say probably understood iron. W.L. Lindsay. He if there's anybody who's going to understand iron and soil, it's going to be Lindsay. I don't even know if he's still alive anymore or not, but he is at the top of the list. And in this paper, which goes over all of his sort of past papers, this was published in 1982 in Journal of Plant Nutrition, kind of went over all of his past papers and summarized the findings. And in this paper down here, a little ways through it, he has a statement in the text of this. And this is a very complex paper, exceedingly difficult to grasp and understand. I've been reading this paper for 15, 20 years, and it's still difficult for me to really, I still pull something out of it usually. And this is an example of that. I pulled this out of this paper, which I wouldn't have necessarily thought I would ever use. On page 883, it states, it appears that Fe2 in solution is the solution species of iron that is most likely absorbed. Okay. And its concentration determines iron availability to plants. So Fe2, remember Fe2 and Fe3 exist. They're species of iron that exist in the soil, and they exist based upon what the redox potential in the soil pH is. But it appears that Fe2 is what is absorbed by the plant. Thus, reduction plays a very important role in uptake of iron. So reduction is the gain of electrons. So you've gone from you've gone from Fe3 to Fe2. That would be a reduced state of iron. That's the reason he's saying reduction plays a very important role, because oftentimes it's Fe3 that exists in the soil solution. So if we reduce it to Fe2, he's saying that plays a very important role in uptake, because he's saying that it looks like Fe2 is what's taken up. The findings of Brown and Ambler in 1973 and Cheney in 1972 the findings that reduction by root exudates is an important mechanism for iron uptake is certainly supporting evidence. So these authors, Brown and Ambler in 73 and Cheney in 1972, published and determined that the exudation of root natural chelates, phytosterophores, is what we refer to them today, plays a tremendously important role in the reduction of that iron around the rhizosphere, around the area of the root that is in intimate contact with the soil. A very, very small area, a very, very thin layer around the root surface. When the plant exudes these chelates, they play an important role in reducing that iron down to Fe2. Okay? We further found that iron-stressed plants released greater quantities of these reductants to the nutrient media than non-stressed plants. This was Schwab and Lindsay in 1982. Now, he was doing work with soybeans. And we were able to show that the redox near stressed plants' roots may drop to as low as a redox plus pH of 4 to 7. I'll go into that in the future if I need to. In this redox range, reductive processes certainly are more important in making iron available to plants. Okay, so let me sum all this up. Oh, I didn't even put that on there. I'm sorry, I didn't have it on there. I apologize. This is what I'm talking about. For those listening, you didn't see anything different. But this, for those watching, I was reading this. I can't do 5 things at once. I'm sorry. This is what I'm talking about. Okay, this article right here by Journal of Plant Nutrition, Chemistry of Iron and Soil. So those watch on YouTube, they thought I was crazy because I was reading this. I thought it was on screen. But this is where I read this from. Okay, 883. All right. Now, let me summarize that. What they're saying is that it's been clearly shown that the natural exudation of chelates, or the exudation of natural chelates at the root rhizosphere, at the rhizosphere area, will play a role in reducing the iron down from from Fe3 to Fe2 and maintaining it a little bit more soluble in the Fe2 form. And that will be taken up into the plant. And they further found that iron-stressed plants exude more of that. So how does that connect to what we found today in this paper? I'm convinced, maybe not strongly convinced, but I'm convinced that because the turf grass in that paper was severely iron deficient, it's possible, if not probable, that the exudation of natural chelates, phytosterophores, in that setting were to an extent great enough to maintain the solubility of iron from iron sulfate. Whereas in most normal settings where the iron stress plant the plant is not that stressed from iron, you're not going to exude that same magnitude of chelates. The plant is not going to exude that much of it compared to when it is stressed. And so you wouldn't necessarily see a response to granular iron sulfate when the turfgrass is not severely iron deficient. Okay. I hope that makes sense. I didn't want to get too complicated, but that paper is exceedingly rare. The findings in that paper are exceedingly unusual and rare, but the setting was also rare. That wasn't a quote unquote iron deficient turf. That turf was so severely deficient in iron. The color was a 2, even when you applied nitrogen. So in that case, you have such a severe deficiency in iron that it's likely that the roots are exuding a chelate to an extent much greater than when the plant is only moderately deficient in iron, or maybe not even deficient in iron. You're just wanting a little extra color. Okay? That's what I got on that. All right? So it's probably a little bit more than you were hoping to get to from me today. I don't know, but I do think that it's still very unlikely to ever see any value to applying iron sulfate, granular iron sulfate. But in this case, if you have a severely iron deficient turfgrass, it is possible. All right, I'll be on tomorrow at 10 a.m. as usual. I'll be on Wednesday night at 9 p.m. But that'll be it until Christmas. I'm going to maintain my Wednesday night show throughout the holidays. It won't change. I'll be on Wednesday night at 9 p.m. Eastern time throughout the next month or two, whatever. But the remaining Monday, Tuesday, Thursday shows will be, paused after tomorrow. I'll do tomorrow's show, and then I'll be on Christmas holiday for 2 or 3 weeks, whatever it is, when my kids are home. Okay, guys. I really appreciate everybody coming today. I hope it went well. I did something different today, and I'm not sure if it was working or not. I'll when I hang up here, I guess I'll find out. But unless there's any questions from anybody in the chat, I'll let you go for today, and I will be back tomorrow morning at 10 a.m. Eastern time. I hope you found it useful. Be kind. Bye.